Hello, this is Mrs. Ringrose, and we are back at it again for our first video from Chapter 2. We're going to hit the ground running at our next class meeting and talking about how we can change conditional statements into other kinds of statements that we're going to need for proofs. So it is really important that you have a good understanding of what a conditional statement is and how to at least write a definition as a conditional statement. And if you get that out of this video, then that is great. So if you look at the statement I have right here, if it is raining, then there are clouds in the sky. You'll notice that there's an if and then there's a then. So when we have something in a form like this, where you have something that's called a condition and then what comes out of it, we will call this a conditional statement. And we're going to fill out this vocabulary table in just a second. But I really want to point out that the part that comes after the if is called a hypothesis. And hopefully I spelled that right. If something is happening, then something else. All right, and then the part that comes after then is what we can conclude. So if it is raining, then we can conclude that there are clouds in the sky. And I'm sorry, I'm going to keep that blue also. Alright, so all we're doing with this video is we're going to take definitions that we know and turn them into a conditional statement, which we like, just to make it look easier, we like to put conditional statements in an if-then form. Alright, so then again, a conditional statement is a logical statement, because we're talking all about how to form a logical, justifiable argument throughout this chapter, is a logical statement that has two parts. And the two parts are listed above. So we have a hypothesis and then we have a conclusion. The if-then form is the form that we're going to appreciate the most, because we know right away what the hypothesis is, and we know right away what the conclusion is. All right, so the hypothesis is the part that we're saying, if this is the condition, and then the conclusion is what the result is from that. And sometimes we're going to write it like this. All right, again, the if part contains the hypothesis, and the then part will contain the conclusion. Okay? And I'm not really sure why I have to have it written out again. So if you want to, if, then. I don't really have anything else to add with that. So that was easy. Last thing I wanted to say was negation. All right, negation is the opposite of the original statement. So kind of thinking of it as the negative. And this is actually really important for when I see you next time. Opposite of the statement. All right, so, and we're going to see some examples in a little bit, but again, like if you were going to say, Mrs. Ringrose came to school today, then the negation of that would obviously be Mrs. Ringrose did not come to school that day. One thing I'm going to add about hypothesis and conclusion, so again, the if is kind of the condition. So if it is raining, and then is the result. You might be comfortable with the words hypothesis and conclusion, but if you're not, you can kind of think of it in those terms. All right, so some vocabulary for you. And then this is the only other thing I'm going to do with you. I just want to go over some steps to rewrite a statement or a definition into that if-then statement so that you're comfortable with seeing how to do this. All right, so all birds have feathers. Believe it or not, that's a conditional statement. All right, the question is, can we put that into an if-then form to make it more clear as to which part is the condition and which part is the result? So we can rewrite this to make the condition of an animal being a bird. If an animal is a bird, all right, then what's the conclusion? then it has feathers. Okay, right? So I have everything I need turns into this if-then form. If an animal is a bird, that means it's all birds, then it has feathers. All right, the next one is actually a math definition that you're probably already familiar with. Two angles are supplementary if they are a linear pair. So this one actually is kind of helpful because it gives us the if part. If two angles are a linear pair, then they are supplementary. So sometimes when I really like this example because sometimes when you're turning it from a statement that is not an if-then form into it, we sometimes have the tendency to just keep it in the same order. So listen very carefully. If I said if two angles are supplementary, then they are a linear pair, if I wrote that backwards, it might not necessarily be true because you know not all supplementary angles are a linear pair, right? But if I kept the if-then and put that in front, that's my condition. If two angles are a linear pair, then I can conclude that they are supplementary because that is part of the definition of it. All right, so I hope that helped. All right, next one is a definition again, just like part A, but it's a math definition, so we're going to treat it the same way. All right, all angles are right angles. So first we have to meet that condition and maybe say something like if an angle measures 90 degrees, then it is a right angle. Okay? And then, really quickly, I'm going to wrap this up. We can extend this to an equation also. If 2x plus 7 equals 1, you would go through some solving steps and you'd find out then x equals -3. And that one would work, either way. All right. So what we just did was we took statements that were not in if-then form. Believe it or not, they were all conditional. We just turned them into if-then form so that we can see the conclusion and the hypothesis more clearly. All right. And then real quick, 2 examples on negation, and then we're done. This might seem very easy, but we're just going to make sure that we understand when we negate something, we turn it into the opposite. So if the statement is the triangle is equilateral, we use the sign for negation. Bloop. We would rewrite it. The triangle is not equilateral. Whoa, so hard. Okay, and then the last one, if there's already a negative word in the sentence, when you take the opposite of an opposite or the negative of a negative, it's going to turn back to positive. So if I'm going to negate this statement, you would rewrite it, the polygon is convex. All right, so I hope that helped you get a little bit familiar with conditional statements and how to write a statement into an if-then form. We're going to go way more in depth next time I see you, and I hope you have a great day. Thank you.